Hello, I'm Toby. I'm going to walk you through how to use the ExtrudedElement library. On any arbitrary object, you can break it up into tiny extruded elements, so you can assemble it after the fact. So first, grab the ExtrudedElement library. It's simply a text file, which you'll save as a file.scad with the extension SCAD. After downloading OpenSCAD free CAD software, you can then paste the EELLC_lib.scad, the extruded element library, and get started. So in the top of this text file are all the inputs that you'll need to manipulate extruded elements and the objects you'll want to interface with. It's about the top 60 lines of effective code. If your view doesn't gray out the comments, then I would recommend going to Preferences and adjust the coloration of the editor right here, because it kind of looks overwhelming unless the colors are different. So the first step is to choose your element that you want to work with. For instance, here I'm working on a frisbee. So I would want my elements to be solid, because when I throw the frisbee, I think that having elements that are just ligaments or holes through my element array, would cause the frisbee to behave abnormally. So I press key F6 to get the initial, what the settings are when I copy and pasted the library. So here it's looks like a n by n 10 by 5 array of triangular ligament elements. So since I wanted a solid element, I will go to eFill, element fill, and instead of 0 for ligament only, I'm going to change that to a +1 for a filled element. So I simply adjust the value, press F6 again to see the result. And now the elements have changed to solid elements. So you can then see that the hooks are maybe smaller than desired. For attaching a frisbee, you want it to be a little more robust. So I would go then to S_H for size of the hook. The size of the hook is at a 1. I would say I want it 5 times larger. So 1 to 5. And that looks about right for what I'm looking for. And since a frisbee takes a lot of impacts when it falls to the ground, I would like to not have these rounded or squared off edges. I would like that to be rounded. So there are 2 types of hooks here. 0 is a square hook, and 1 under type _H is a rounded hook. So I'll change the type of the hook to 1. Press F6 yet again to regenerate it. So now there's a little bit less stress concentrations when at the interfaces between elements. The next step, so now that we're happy with our element shape, is to bring in our object. So those were the basic options we were fooling around with right here in this top section. Now that I want to bring in an object, I can scroll down to Imported STL Object Options. The very first is file name. In the same directory where you've stored this SCAD file, you'll need to store the STL you'll want to work with. And I want to do a frisbee, which I've appropriately called frisbee. So I type in the appropriate name, and initially S_OBJ is the scaling factor, so I'll just scale it to 1. Its original size. And scrolling down here, in these bubbly parentheses, these lines are supposed to be markers to show you this is the executed code for the whole program. The rest is just modules being called. So right now it's using tessellate to create this tessellation of your elements. If you would like to extrude those elements, you go down one more to this linear extrude line where it says visualize 3D extruded element array. And you just delete the 2 backslashes and see what happens. when you press F6. Now they're extruded elements. They're not just interlocking elements. So there's a solid representation of what the elements are. So to bring in our object, I'll keep going down to one line down. It says visualize object. So what this does is it imports whatever you put in file name. So mine's frisbee.stl. It scales that frisbee. It rotates the frisbee if needed. And it translates the frisbee to line up with these extruded elements. So I'm going to see what it does when I bring in, oh, it's so tiny. And if you recall, those elements were quite a bit bigger, spanning over a value of 600 or so. So I would like to say these are millimeters because my slicer is defaulted to millimeters. I'd like a frisbee, let's say 500 millimeters wide. This looks like about, I don't know, 20 millimeters in diameter, the current frisbee. So I'm going to adjust that to 20 times 25 will give you 500 millimeters. Oh, that's a big frisbee. So it looks like maybe the radius was that. So let's back it off to 15 and press F6. Every time a new visual is popping up in the window here, that means I'm pressing F6 to make it happen again, to render the image. So that's a good position. And if my object came in, if I turn all these translate values down to 0, the object came in right on the center. But I need to translate it so it lines up with the elements. Rotation is not necessary because this is maybe it is necessary, excuse me. So 90-degree rotation is necessary to get it flat and perpendicular to the extruded elements. So now that my object is in position, I'd like to bring the elements in. To do that, I can simply delete these backslashes. This is not too important to visualize. It actually would take an extremely long amount of time while I'm recording my screen. So I'm just going to show the next step after you visualize your elements and made sure they overlay your object properly, is to uncomment this intersection portion. There at intersection and the closing bracket down here on the lower line. Doing this uncommenting intersection function will find the intersection where your where your linear extruded elements intersect with your frisbee. That will give you your final object. And there that finalizes the visualization of the extruded elements of your object. The next video will show you how to actually print these or separate them out for printing.